5, 2, and 5, 4. No. No. I'm not opposed to semester tests, but normally we don't end up running out of time to actually give a semester test. Because if I would want to have enough time to finish this chapter, test over it, and then have enough time to review and then test again. We just never do. We always run up right to the bell. So, looking at this here, this is another one of our solving. We have square root of 2x equals the square root of x plus 7 minus 1. Now, is there one radical? No. If not, we have to even them out. So we have two radicals, so we need to have one on either side. Okay, we're good there. Now, if we had 3, well, there's no way to even 3 out. So that means we're going to have 2 on one side, 1 on the other. Or 1 on one side, 2 on the other. So we just end up with 2. If we had 4, we would want 2 and 2. So here, that's fine. Which means we can move to step number 2. We're going to put both sides to the second power. Now, on the left side, the square root and square would cancel because since we only have one term, we're multiplying it by itself. The square root's going to go away. On the right-hand side, well, we have two things being subtracted. So that means we're going to actually have to multiply this out. We're going to have to distribute this all the way out. Question so far? Since we have that square root minus 1, 2 terms being subtracted, we can't just square the square root and square the 1. We have to actually distribute out. Kind of like what we had with p plus 1 yesterday. 2 terms being added or subtracted, we have to multiply out. Now the first one, so we have 2x. You know what? I'm going to do this. We're going to do this square root of x plus 7 times the square root of x plus 7. Which we can just say is the square root of x plus 7 squared, because squaring is multiplying it by itself. Well, the nice thing with this is that that square root and square is going to cancel, is going to simplify out to just x plus 7. That is the nice part about that one there. Questions on this so far? I was just simplifying that at this point. We still have to finish multiplying. Our square root of x plus 7 times negative 1. So the negative 1 will multiply out front, really just telling us that we have negative square root of x plus 7. That negative 1 and the number in front of that radical, which is 1, multiply together to give us negative, and our square root of x plus 7. All right. Now we're going to do the same thing with the negative 1. Negative 1 times our square root of x plus 7. Again, just going to give us negative square root of x plus 7. Negative 1 times negative 1 is positive 1. Now, at this point here, we're going to have to combine like terms. Now, since those radicals are the same, and I have negative 1 of them, and I'm going to subtract 1 from it, negative 1 minus 1 is negative 2 square roots of x plus 7. Because they are the same radical, we can add and subtract their coefficients. Negative 1 minus 1 is negative 2. Now, before we move on to the next step, we need to finish combining like terms. Because that 1 at the end and that 7 are like terms, telling us that we have x plus 8 minus 2 square roots of x plus 7. Questions on this here? So for the most part, I mean, from what we did yesterday, there's not a whole lot different. there's a lot of term stuff we're having to multiply radicals this time. Okay. Questions on this so far? All right, now we're going to actually look at a step we've pretty much been ignoring up to this point, which is step number 3. Step number 3, are there any radicals left? If so, repeat steps 1 and 2. So that means we go all the way back to the top. Step number 1, is there one radical? If so, get it by itself. So yeah, so we just repeat the process. So we will eventually, but I would move everything over first because we're wanting to get this square root of x plus 7 by itself. So one of the things we can move first is x, because x minus x over here would give 0, leaving us with 8 minus 2 square roots of x plus 7. On the left-hand side, 2x minus x is x. Then the next thing we can subtract is 8 minus x minus 8 is equal to negative 2 square root of x plus 7. So we are going to move the x's over. We'll subtract x. We'll subtract 8. And now the last thing we have to move is what? The negative. We're going to divide both sides by negative 2. And what that'll give us is x minus 8 over negative 2 is equal to the square root of x plus 7. Yep. So questions on this here before we start our next step. So we got the radical by itself, yes? So now we're going to put both sides to the nth power. Our nth power in this case is 2. Now this time I'm going to focus on the left side, or right side first, because that square root's the only term on the right side, so when we square it, the square root and square will cancel out, which is nice because now we won't have any radicals left. But let's look at the left side. Now, as long as we don't have addition and subtraction on top or bottom, we can just square the top and bottom. Yes? Oh, wait a minute. What do we have on top? X minus. So we're going to have to actually multiply this by itself. So we're going to have to distribute this through. Now, we'll do the denominators first, because when we multiply two fractions, we have to multiply numerators with numerators, denominators with denominators, tops with tops, bottoms with bottoms. So if we look at the bottom, negative 2 times negative 2 is positive 4. That's the main reason I started there, because that one's nice. Now, if we look at the numerators, well, x times x is x squared. X times negative 8. Negative 8x. Then negative 8 times x. Negative 8x. And lastly, negative 8 times negative 8 plus 64. Combine like terms, negative 8x and negative 8x would give us negative 16x. Questions on how we got to this point here? Now, at this point, the only thing that's really daunting about this problem at this spot is that fraction, that division of 4, yes? It would be very nice if I could say, multiply this by 4. And if that polynomial, that quadratic's being divided by 4 and I multiply by 4, well, the division 4 and the multiplication of 4 would cancel. which would leave us with x squared minus 16x equals 64. But we can't just do this to one side. We have to do it to the 4 times x is 4 times 7 is. Because this is scaling it. We're scaling it up so that we don't have that division of 4. We get rid of that and makes this problem a little bit nicer. You can do this with any problem. Because if we said we just had decimals across the board, we can multiply by 10 to a power either 10, 100, 1,000 to remove that decimal or remove that coefficient that is in common. Well, we don't have any radicals anymore. So now we can just move to solve. Because if we did, we'd go back and repeat steps 1 and 2 and keep doing that until they're all gone. We can subtract 4x from both sides. Telling us x squared minus 20x plus 64 is equal to 28. Subtract 28 from both sides. Minus x squared minus 20x plus 'Third term's positive, so the signs are the same and match the sign of the middle term. Negative and negative. Only factors for our first term are x and x. Factors of 36. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which ones do we want to try first? 2 and 18, yeah. And those are the correct factors. So since we have two things multiplied together equals 0, one of these is going to have to be 0. Questions on this here? Would we say that this is harder than what we've been doing? God, I'm saying it's not harder. It's a lot more steps. That's really the only difference. A lot more steps. All right, guys, guess what? We need to check. So we need to check and make sure that these solutions work and not extraneous solutions. So at this point here, we could type the whole thing in the calculator. Well, not the whole thing. We can tap each side and simplify that there. Here, I'm just going to go on and work it out. 2 times 2 is 4. Square root of 4 is 2. On our other sides, 2 plus 7 is 9. So it gives us the square root of 9 minus 1. Square root of 9 is 3. 3 minus 1 is 2. These are indeed equal, so it does tell us that 2 is a solution. We can do the same thing with 18. 2 times 18. 18 plus 7 minus 1. And again, we can type each side of this into the calculator and see what we get. So if we wanted to, we could say the square root of 2 times 18 in the calculator, and it would tell us, well, 2 times 18 is 36. Square root of 36 is 6. So the calculator would just tell us it's 6. On the other side, 18 plus 7 is 25. Well, the square root of 25 is 5. 5 minus 1 is 4. So it would tell us that 6 is equal to 4. Well, that is not true. So the only solution that we have is that x is equal to 18 did not work. Questions on this here? Question on anything we've done? Are you ready for the next one? Please. 10 points. So again, I'm giving you this other one as a bonus assignment. 10 points if you want to do it. If not, again, it's bonus.